Have you ever wondered how Mars, once a water-rich planet, became the cold, dry desert it is today? This red planet, our neighbor in the solar system, has a fascinating story to tell, and it all starts with the mystery of its lost magnetosphere. Imagine the magnetosphere as an invisible shield circling a planet, protecting it from the harsh solar wind. Around 4 billion years ago, Mars had such a shield, but in a twist of cosmic fate, it lost this protective layer. The prime suspect? A barrage of asteroid strikes. These celestial projectiles may have stripped Mars of its magnetosphere, leaving it vulnerable to the relentless solar wind. Imagine a gust of wind blowing across a sandy beach, gradually eroding and carrying away the grains of sand. In the case of Mars, the solar wind acted in a similar fashion, interacting directly with the Martian ionosphere, the upper atmospheric layer charged with electricity. This interaction caused a steady stripping away of atoms from the outer layer of the Martian atmosphere. Over time, this relentless process significantly lowered the atmospheric density of Mars. Our planet Earth has a magnetosphere that protects us from such a fate. But for Mars, the loss of its magnetosphere was a game changer. This dramatic event changed the course of the planet's history, setting the stage for its transformation. The once water-rich Mars began to lose its atmosphere, turning into the dry, desolate desert we see today. The evidence of this atmospheric loss is still visible today, with ionized atmospheric particles trailing off into space behind Mars. This intriguing phenomenon is being closely studied by the Mars Atmosphere and Volatile Evolution, or MAVEN, orbiter. So the absence of a protective magnetosphere was the first step in Mars's transformation into the planet we know today. But the mystery of Mars doesn't end here. And as we continue to explore and understand this intriguing planet, who knows what other secrets we might uncover? If you were standing on Mars right now, what would the atmosphere feel like? A thought-provoking question indeed. Mars, the red planet, is a world with an atmosphere that is quite unlike our own. Let's begin by considering atmospheric pressure. On Earth, we're used to a certain amount of pressure, about 14.7 pounds per square inch at sea level. But on Mars, the story is different. The atmospheric pressure varies, with the highest being about 0.1675 psi in the Hellas Planitia, a massive impact basin, to as low as 0.0044 psi on Olympus Mons, the largest volcano in the solar system. That's a far cry from what we're accustomed to here on Earth, and it's one reason why humans can't survive unprotected on Mars. Now let's talk about what the Martian atmosphere is made of. It's mostly carbon dioxide, about 96%, with small amounts of argon and nitrogen, and traces of oxygen and water. This makes the Martian atmosphere quite different from Earth's, which is primarily nitrogen and oxygen. Interestingly, the Martian atmosphere is dusty. Particles about 1.5 micrometers in diameter fill the air, giving the Martian sky a tawny color when seen from the surface. And sometimes it may even appear pink thanks to iron oxide particles, better known as rust, suspended in the atmosphere. Now here's a fascinating tidbit. The concentration of methane in the Martian atmosphere fluctuates seasonally. It ranges from about 0.24 parts per billion during the northern winter to about 0.65 parts per billion during the summer. This presence of methane is intriguing because it could be a sign of active geological processes or perhaps even evidence of life. Despite its thinness, Mars's atmosphere is a complex and dynamic system. It's a world of extremes with an atmosphere that is both fascinating and challenging. As we continue to explore Mars, who knows what other secrets we'll uncover about its atmospheric phenomena. Did you know that sound travels differently on Mars than on Earth? And that Mars has its own version of the Northern Lights? It's all about the atmosphere, you see. The atmosphere on Mars is primarily made up of carbon dioxide, almost 96%, with traces of argon and nitrogen. It's also much thinner than Earth's atmosphere, with a surface pressure that's only about 0.6% of ours. This higher concentration of CO2 and lower surface pressure create a unique acoustic environment. Natural sound sources on Mars are few and far between, with the wind being the prime orchestra. The way sound moves through this rarefied air is different from what we're used to. Researchers working with acoustic recordings from the Perseverance rover discovered that the speed of sound on Mars is approximately 240 meters per second for frequencies below 240 hertz. And 250 meters per second for those above. But the Martian atmosphere doesn't just affect sound. It also plays host to a light show that's different from anything we have on Earth. I'm talking about auroras, Mars style. Unlike Earth, Mars doesn't have a global magnetic field, which changes the way auroras form. Instead of being confined mostly to polar regions like they are here on Earth, Martian auroras can envelop the entire planet. Imagine a sky lit up with an aurora 25 times brighter than anything we've ever seen on Earth. That's exactly what happened in September 2017, when a massive and unexpected solar storm temporarily doubled radiation levels on the Martian surface and triggered an incredibly bright aurora. So, while Mars may lack a magnetic field, it's far from being a dull place. From the unique way sound travels through its thin CO2-rich atmosphere to the planet-wide auroras that light up its sky, Mars is a world of its own. Mars may not have a magnetic field, but it still puts on a spectacular light show. How do the seasons on Mars compare to those on Earth, and just how cold does it get? If you've ever wondered about the Mars weather forecast, buckle up. You're in for some fascinating facts about the red planet's climate and the reasons behind it. Like Earth, Mars experiences 4 distinct seasons. However, the Martian year is roughly twice as long as ours due to its greater distance from the Sun. This means that each season on Mars lasts about twice as long as it does on Earth. So, while we may grumble about long winters, imagine enduring a Martian winter that lasts nearly a year. But the Martian seasons aren't just longer, they're also more extreme. One of the primary reasons for this is Mars's thin atmosphere, which can't store much solar heat. This leads to a wide range of surface temperatures and some pretty extreme weather. How extreme, you ask? Well, in the height of a Martian summer, temperatures near the equator can reach a balmy 35 degrees Celsius. That's about as warm as a summer day in some parts of Earth. But don't pack your beach towel just yet. When winter rolls around, temperatures can plummet to a bone-chilling negative 110 degrees Celsius. That's colder than the coldest temperature ever recorded on Earth. These wild temperature swings are due to the thin Martian atmosphere and its low atmospheric pressure. Unlike Earth's dense atmosphere, which acts as a blanket to hold in the sun's heat, Mars's thin atmosphere allows that heat to escape back into space. This leads to frigid nights even in the summer. So while we may dream of a summer holiday on Mars, it's worth remembering that the Martian climate is far more extreme than anything we're used to here on Earth. Mars may be a frigid desert, but its seasons are surprisingly Earth-like. So next time you're caught in a heat wave or a cold snap, spare a thought for our neighboring planet and its truly out-of-this-world weather. So what have we learned about Mars's atmosphere and hydrology? We started our journey with the enigma of Mars's vanished magnetosphere, believed to have disappeared around 4 billion years ago. This loss, possibly due to multiple asteroid strikes, has led to the solar wind directly interacting with the Martian ionosphere, gradually stripping away atoms from the outer layer and reducing the atmospheric density. Next, we delved into the present state of Mars's atmosphere. It's quite rarefied compared to Earth, with atmospheric pressure on the surface varying dramatically. The atmosphere is predominantly carbon dioxide, with traces of argon, nitrogen, oxygen, and water. Interestingly, the Martian sky takes on a tawny color due to the dusty atmosphere filled with iron oxide particles. We then explored the Martian sound and light show. Mars' higher concentration of atmospheric carbon dioxide and lower surface pressure lead to sound being more attenuated than on Earth. Plus, Mars offers a unique spectacle of auroras. Unlike on Earth, where they are mostly restricted to polar regions, on Mars, an aurora can envelop the entire planet. We also discussed the Martian seasons and surface temperatures, which are the most Earth-like among all planets in the solar system. This similarity is due to the comparable tilts of the two planets' rotational axes. However, the Martian year is about twice as long as Earth's due to Mars's greater distance from the Sun. Mars's surface temperatures also vary widely, mainly because its thin atmosphere cannot store much solar heat. In conclusion, Mars is a planet of contrasts with an atmosphere markedly different from Earth's. Its lost magnetosphere, rarefied atmosphere, unique sound propagation, breathtaking auroras, and Earth-like seasons all contribute to its intrigue. The more we learn about Mars, the more fascinating it becomes. It's a world of contrasts and mysteries just waiting to be explored.